Hi guys, Mrs. H here. So we're going to be looking at today the Bohr model. So if you remember last week we talked about the different models, and so specifically we're going to look at the Bohr model today, and then later this week we're going to look at Lewis dot structures. So two things that we have to remember is what the electron cloud is and what energy levels are. And so remember, the electron cloud is the area around the nucleus that contains all the electrons. And that electrons are moving at a really high speed in this area, but that space is mostly empty. And then within the electron cloud are energy levels. And the energy levels are the specific locations within the cloud that the electrons are found. And they're associated with the state of energy of the electrons. And so we determine the number of electrons within the cloud, and then that will determine where or how many energy levels there are. So as a review, remember our period is, or the rows, determines the number of energy levels each atom has. So if I'm in period 3, I will have 3 energy levels. Or if I'm in period 5, I will have 5 energy levels. So the Bohr model is a representation of an atom, and the subatomic particles are going to be placed in the nucleus of the proton and the neutron, and then the electrons are going to be placed in energy levels outside in that cloud of the atom. Now, this isn't as cut and dry and as simple as straightforward as it seems. Because remember, we had said the number of energy levels are determined by the period, and that's true. And the number of atoms in each row does not necessarily tell us how many electrons are in that period, because crazy things start to happen after calcium because electrons don't know where they want to be or where the best optimal energy is. And so it's not necessarily a what's the word? It's not as simple, just to put it straightforward. So after calcium, things get complicated. So if you look at this diagram over here, the first energy level has 2 electrons, just like the first period has 2 atoms. The second energy level has 8 electrons, just like the second row has 8 atoms. However, the third energy level, or the third shell, actually can hold 18 electrons. But if you look over here, period 3 only has only has 8 atoms in that row. So the number of atoms in the row do not tell you how many electrons are in each energy level. Okay, so this is not the same as energy levels or number of electrons in the energy level. However, this does tell you the number of energy levels. So it gets complicated, okay? Now, why does it get complicated? Well, let's take a look at an analogy. So I have a mall, and then in the mall, I have 4 floors. And within the 4 floors, I have different types of stores. I have an electronics store, I have a shoe store, I have a toy store, and I have an appliance store, right? And depending on what floor I have, I could have an electronics store on all of them, but I might not have a toy store on all of the floors, okay? And so that's kind of what happens with orbitals. So each energy level is going to have a different orbital. An orbital is a spin or movement of the electron. And so each energy level can have a different orbital. but not all of them are in all of the energy levels. And so that's what we're seeing here. And as a result of this, everything after these right here gets complicated. The electrons don't really know which way they want to go. And so remember when we talked about transitional metals and not being able to determine the number of electrons straightforward from just looking at the periodic table? Well, this is why, okay? So let's look at how a Bohr model is constructed. So there's 4 rules in constructing our Bohr model. So let's try sulfur. So the first thing we need to do is determine the number of protons, neutrons, and electrons in an atom using the periodic table. So sulfur has 16 protons, 16 neutrons, and 16 electrons. So what I do with this information is I put P equals and N equals, both 16, in a circle. Okay, that's going to represent the nucleus. The next step is I need to determine the number of energy levels or rings I need to draw. So if I look here, here's sulfur right here. And so sulfur is in 1, 2, 3, period 3. So then I need to add 1, 2, 3 dashed lines to represent the 3 energy levels. The next thing I need to do is put in dots on the energy levels. Okay, and so that's what we see here. So remember, I have 16 electrons. The first 2 electrons are going to go in the first energy level or the first shell. But I have more than 2. So now I go to the second energy level. So the second energy level can only hold 8 electrons. So I'm going to fill it up because 2 plus 8 is 10 and sulfur has more than 10. So here I have 1, 2, and then 2, 4, 6, 8. So 2 plus 8 equals 10 electrons. That means I have 6 electrons that I need to place in the outer energy level. So I'm going to do 2, 3, 4, 5, 6. And so this is how we construct our Bohr model of sulfur. I do want to make a point here. Notice how the electron dots are arranged in kind of this very organized pattern. I do suggest you do that because it's only going to help you keep count and keep track of your electron placement on your energy levels. Okay, so let's go ahead and do another practice, but this time we're going to do it by hand. So I am going to do a Bohr model with fluorine. So here's fluorine over here. So the first thing I need to do, step 1, is determine the number of protons, neutrons, and electrons in fluorine. So if I'm looking up over here, I'm just going to jot these down in the corner. The number of P's is 9. Okay, so that means I'm going to have 9 electrons as well. And so the number of neutrons, 19 minus 9 is 10. Okay, now the other thing I'm going to do, since I already have it out here, I want to determine how many rings it has. So it's in the second row. So that means it has energy levels is 2. Okay, so I have the information I need all set up. So I'm going to go ahead and construct a Bohr model. So the first thing I need to do is do my nucleus. So there are 9 protons and there are 10 electrons, and I place that within the nucleus. So now step 2 is determining our number of energy levels, which is right here. So I already have done that. So there's 2 energy levels. So that means I'm going to set up my dashed, right? There's 1. And now here is 2. Now be careful if you're doing this by hand and setting these up, because you don't want these to overrun, because then it kind of looks difficult. It's hard to determine which energy level is which. So here I have 2 energy levels. And so that is our step 3. And so now I need to place the electrons within each energy level. So remember, energy level 1 has 2 electrons. So I'm going to put 1, 2 electrons. So there's my dot. So then if I recall, energy level 2 can hold 8 electrons, but I only have 9, right? So I only have 9 electrons. I've already placed 2, so 2 minus 9 is 7. So I'm going to do 1, 2, 3, 4, 5, 6, 7 electrons. So if you look, I have a total of 9 electrons on my model, 2 in the first energy level and 7 in the second energy level. Now, remember what we talked about valence electrons and how we determine valence electrons? So remember, all of my atoms in this group right here have, remember, 1, 2, 3, 4, 5, 6, 7 valence electrons. And if we look at the definition of valence electrons, it's the number of electrons in the outer energy level. Well, look what we have here. 1, 2, 3, 4, 5, 6, 7. 7 electrons in the outer energy level. So I hope this was helpful for you to see it done by hand as well. So this is what we're going to be practicing on. Make sure you're reaching out to me and asking for help when you're struggling. Have a great day, guys. Bye.